Welcome to this problem where we have this Jenny 3 meter from lamp post when she started running. So actually, right, if you see this 3 meter, where is it? It actually coincides with this point here on the graph, as this y measures the distance from the lamp post. Okay, after t seconds, and we are given the equation. And very first thing that they actually ask us is, what is the gradient of this line? So I'm going to just focus on this particular equation here, and we just need to compare with the general equation of a straight line or linear graph. And we can actually see that, do take note, this m actually represents gradient, the number. The c represents the y-intercept. That means the point where it cuts the y-axis or the vertical axis. And the next two things that you should see and look out for actually is, well, the x-axis or the vertical or the horizontal. So let me just put it at one side. This one actually is referring to the horizontal axis, the variable down there, and this represents the values on the vertical axis. Usually we use letter y, as you can see here. So if I color code all, you would then see that if we are given the linear equation, then just by comparing and observing, we would be able to get the answer for part A pretty easily without any working. Yep, that's the answer. That's the gradient of this line. The second part though requires some thinking, and the context here is that y is actually a distance, and the t or the x-axis is actually the time. And how exactly do we find gradient? Well, if you remember previously, the gradient is the change in y, meaning y1 minus y2 over x1 minus x2, the change in x for the horizontal axis. And if I were to piece everything neatly now, you would then see that the vertical axis in this question is represented by what we call the distance. Horizontal axis x, we are actually looking at time. And what exactly is distance divided by time? Yes, distance divided by time. What quantity does this represent? Yes, speed. And in this case here, the gradient here then tells us something about this speed. Yeah, because it is a straight line, and in this case we are actually looking at speed of 2 meters per second, and because it is a straight line, meaning at any point on this straight line the speed is 2 meters per second, so we could actually use the word constant speed. So we just need to write it represents a constant speed of 2. In this case, you are looking at meter per seconds. With that, we have come to the end of this particular question. So if you like this video at any point in time, do give it a thumbs up and do subscribe to my channel for more of such content. Yeah? Thank you for watching and have a nice day. Hello everyone, welcome to this problem on linear graph, and we are given the equation of the line, and that's the first thing I would like to highlight. And we are also given some corresponding values of x and y in the table below. So let's go to part A, where we are required to find the value of A. Do notice A is my y, x is my 20. So this question basically means, what is the value of y when x is 20? Y will be A equal 15 plus 0.2 multiplied by x, in this case 20. So we are essentially just looking at this pair, and we just need to then use our calculator to give us a value of 19. So A is 19. Next, given this table of values, our task now is to use a scale of 2 cm. 2 cm is usually the big box to represent 10 units, and scale of 2 cm to represent 5 units for the x and y axis. So this is what we are going to do next. Alright, so given this axis, I will then proceed to draw the graph. So this will be my y, this will be my x, and 0 is here. For the x-axis, which is the horizontal, each 2 cm is 10 units. So you will see 10, 20, 30, and 40. And for the y-axis, it will be 5 units all the way until 25. So you will see I have 5, 10, 15, 20, and 25. Now we just need to refer back to the table. When x is 0, y is 15, which is this point here, where my x is 0, my y is 15. The next point, x is 20, y is 19, which will correspond to this particular point here. Every 2 small boxes represent 1 unit. So at this particular point, we would then have 20 for x, 19 for y. And for the last part will be my 40 and 20, this point here. X is 40, y is 23, 21, 22, 23 will be here. And after which, please use a ruler and join this line neatly. And very importantly, do write down the equation of the line. So I cannot emphasize any further. This is a must to write down. So To really emphasize this, please write it equation of the line near to the line that you are actually drawing. All right. Now with this graph, then we can start to answer questions for part C. Notice, this is a very important keyword. From the graph means that we do need to show our working in the graph. Find the value of y when x is 12.5. So I'm going to go to 12.5 here, which would be here. I'm going to zoom in. 12.5 is here. So draw this dotted line because this serves as a working. So it will be 17.5 here. This is for C, part 1. So I cannot emphasize further. Please do draw the dotted lines as working, that you are indeed using and finding the answer from the graph. So in this case here, I would have gotten 17.5. As for the next question, find the value of x when y is 20. So again, I'm going to zoom in to the graph. Y is 20. Again, do make sure that you are indeed drawing this dotted line, because then, and also do label this down. Okay, so I also would like to emphasize that do label which part of the question this working is from, and also do draw all these dotted lines so that we could ascertain that you are indeed getting all these answer from the graph. These are some pointers that will help you when you do and attempt this question. Alright, so please do take note of all these pointers, and with that, let's move on to the next question. Hello everyone, welcome to this question where we are given the linear graph. And well, part 1, the question is quite straightforward. So let's just zoom in. They will want what is the coordinates of this point here. X is 0, y is 4. So that will be the answer for part 1. X is 0, y is 4. Okay, just to indicate down there for easy reference. Now, gradient of this line though, we do need 2 points to find the gradient. So I'm going to just probably find a convenient point. You can find any point. So for this purpose of this case, we will have x is 4. I'm going to choose point B. Y is 16. And I'm going to just name this as x1, y1, x2, y2, such that when we apply the formula for gradient, y1 minus y2 over x1 minus x2, you will then be able to see that all we have to do is to make sure we substitute the values correctly. So in this case here, you will see this 4. Yeah, so 4 minus 16, and there is part here, and over 0 minus 4. And you will be able to get the answer as 3. And now for the last part, state the equation of the line AB. Do notice they actually use the word state and not find, meaning that if we know the answer for part A and part B, we will be able to write the last part down easily. Please remember, this is the general equation of a line. And M actually represents gradient. C represents y-intercept. And so in this case, we got these two numbers, 3 and 4. This is the point where we actually cut the y-axis, 4. So this particular question, we only require you to write down 3 x plus 4, since 4 is positive. And that's the answer. That is the equation of the line AB, where we have successfully find the gradient and the y-intercept. And that concludes this particular question. So at any point in time, if you like this video, do give it a thumbs up. And if you like the content this channel is publishing, do subscribe to this channel. Thank you and have a nice day.